Hello everyone, welcome back to Infinity Physics. In this lecture, we are going to discuss about uniform and non-uniform motion, and then we will discuss about graphical representation of motion in this lecture. And in the graphical representation of the motion, we will see different types of graphs of motion about uniform motion, non-uniform motion, uniformly accelerated motion, and also we will see all these motions in a distance time relation as well as velocity time relation. This is the part 2 of the chapter 8. In the part 1 I have explained about the distance, displacement, velocity, speed, acceleration, and also about the scalar and vector quantity. So now let us start our discussion on uniform and non-uniform motion. So let us start with an example. Suppose we are moving on a path and we cover a distance. Let us say here we represent distance by s and time t. So here suppose we cover the first 50 kilometer. We are on a long journey. So suppose we cover first 50 kilometer in 1 hour. Now second 50 kilometer in another 1 hour. So total time taken is 2 hours. Now in another 1 hour, right here 1 hour, then 1 plus, so 2 hour, another 1 hour. So here the total distance covered is 100 kilometer. Now in the third hour we have covered the total distance, right, of 150 kilometer. Then in another hour we cover 200 kilometer in fourth hour. So here what you are observing, in the first hour we have covered total distance of 50 kilometer. In total 2 hour we have covered the distance of 100 kilometer. Third hour we have covered the total distance of 150 kilometer. So here every 1 hour we are covering a distance of 50 kilometer. So after 1 hour, that is plus 1, if you do then it is 2 hour, then the distance will be 100 kilometer. So what you are doing here, you are covering an equal distances in equal intervals of time. For example, if you represent the path like this, you are starting from your initial position and this is your final position. So first 50 kilometer you are covering in time of 1 hour, then 100 kilometer you are taking 2 hour, right? So you are covering equal distances in equal intervals of time. For each interval you are covering a distance of 50 kilometer. For the another interval of time you are covering another 50 kilometer. For the third interval you are covering another 50 kilometer. So for equal interval of time you are covering equal distances. So this type of motion is said to be uniform motion. So here how we define it? If an object covers or travel equal distance, equal distances in equal intervals of time, then the motion of the object is said to be uniform motion. When if an object covers equal distances, so here the distance covered in the equal interval, see intervals are also equal, 1 hour, 1 hour, 1 hour. So interval is of 1 hour. So 1 plus 1 2, 2 plus 1 3. And here the covering distance interval, the interval of the distance is also equal. So 50 plus 50 plus 50. So if the object cover an equal distances in equal interval of time, then the object is said to be moving with uniform motion. Now let us try to look at this graph in this motion in the form of graph. So suppose this is your y-axis and this is your x-axis. On y-axis generally we represent either distance covered or velocity or speed. On x-axis we represent time. So there will be time on x-axis always. So here this is distance covered. Let us divide the this distance into equal parts of 50 then 100, then 50 plus 50, 100 plus 50, 150, then here we will get 200. And time, let us say we divide it into 1 hour. So 1 hour, here 2, here 3, here 4. Now, in the first 0, initially time 0, distance 0. Then after 1 hour, the distance covered is 50 meter. In the another 1 hour, the distance covered is 100 kilometer. Then in the third hour, the distance covered is 150 kilometer. Now if you join all these points, what you will get? You will get a straight line. You will get this type of line. So this line represents the uniform motion. And this graph is a distance time graph. Here distance is in kilometer and time is in hour. So this graph is a distance time graph of uniform motion. Now suppose if we take the graph between the speed and the time, or velocity and time, then our graph will look like here. Suppose here we have one graph. So this is x-axis, this is time this is time. Here we represent time, and so time is denoted by let us say here 1 hour, then 2 hour, here 3 hour, here 4 hour, and here we represent velocity or speed on the y-axis. So what is the speed of this vehicle? What is the speed or velocity of this vehicle? The speed is equals to distance covered upon time. Now what is the total distance covered? Let us say here 200 kilometers. So 200 divided by time taken is total 4 hour. So the time taken is 4 hour. So here we will get 50 kilometer per hour. So here the speed is 50 kilometer per hour. It means in 1 hour the object covers 50 kilometer. So here see, first hour 50 kilometer. So here this is the speed. What is the speed? 50 kilometer per hour. So in the first hour the speed is 50 kilometer per hour. In the second hour the speed, again the distance covered in 1 hour is 50 kilometer per hour. Right? The speed, again see here the distance covered, the net distance, this distance is 50 kilometer, because this total distance is 100 kilometer. So this distance is 50 kilometer, and what is the time taken here? 1 hour. So here again the speed is 50 kilometer per hour. Here also distance is speed is 50 kilometer per hour. Here also the speed is 50 kilometer per hour. So in uniform motion means the object is traveling with the same speed, with the constant speed. It is not changing its speed. So that type of motion is called uniform motion. So here the speed of the object, the velocity of the object remains constant. It is not changing. So with the time the speed is not changing. So at the first hour the speed was 50 kilometer per hour. In the second hour the speed was again 50 kilometer per hour. Second hour same speed. Fourth hour same speed. So in all the hour the speed is same. So if you draw a velocity time graph, then you will get a graph like this, a line parallel to time axis, a line parallel to time axis. But for the same motion, if you draw a distance time graph, then you will get a graph like this. Okay, so both the graph represent the same motion, both represent the uniform motion. Now let us look at the non-uniform motion. Now let us try to understand non-uniform motion. So what is non-uniform? Say uniform means same, constant. If the object is moving with a constant speed, then the object is said to be in uniform motion. Or if the object covers equal distance in equal interval of time, then the object is said to be moving with uniform motion or uniform velocity or uniform speed. Here the non-uniform motion means, suppose from your home you are going to cover a distance, a total distance of, let us say, 200 kilometer. You are starting from your home with 0 distance. Now suppose first on going from your home to out of the city, you are covering a 20 kilometer in 1 hour. because there is a traffic. So that's why it will take some time, either half an hour or 1 hour to go out of the city. Now you are on a highway. On highway you are covering this much distance. This is 100 kilometer, right? So that is you are covering a distance of total distance of 80 kilometer in the second hour. See, first hour 20 kilometer, second hour 80 kilometer. So the total distance covered in the 2 hour is 100 kilometer. So don't get confused here. Then here now you are stopping at hotel and going for lunch or something. Then here you are stopping, and every time if we count, then in the another hour, that is first hour plus 1, second hour plus 1, third hour. In the third hour, suppose you have covered a distance of just 40 kilometer. So the 40 kilometer distance means the total distance covered is only 140 kilometer. Now in the fourth hour you are reaching at your hometown or where you want to go. So this is 60 kilometer remaining that you are covering in the another hour, that is in the fourth hour. Generally we are representing R as a H only. R is not required. So here now here you can see in the first hour you are driving very slowly. In the second hour you are driving very fast. In the third hour you are traveling with an average speed. So here what is happening, your speed is changing or your velocity is changing. You are not covering equal distances. In the first interval you are covering only 20 kilometer. In the second interval you are covering 80 kilometer. In the third hour or in the third interval you are covering only 40 kilometer. Right? So this type of motion is called non-uniform motion because your speed is not uniform, your speed is not constant. So here we can define the non-uniform motion as if an object covers unequal distances, if an object covers unequal distances in equal, see intervals of time are equal, 1 plus 1 plus 1 plus 1. So time intervals are equal. So here in equal intervals of time. So such type of motion is called non-uniform motion. Now let us represent this motion graphically. So suppose you have here distance which we measure in kilometer, and here we have time that we measure in hour or second, but here we will measure it in hours. Now you are starting from 0. Now let me divide this axis into equal parts. So here this part is of 50 kilometer, second part total is 100 kilometer, then the third part again of 50, that is 150, then it is 200. Here I divide it into first hour, this is second hour, this is third hour, and this is fourth hour. Now initially you are at rest, you are not moving at all. Then in the first hour you are covering a distance of 20 kilometers. So this is the first hour here, and the distance covered is approximately this is 20. So if you join this you will get a point here. Now in the second hour, means here you are covering a distance of 80, that is 20 plus 80, 100. So here you are covering a distance of 100 kilometer in the second hour. So here in the third hour you are covering only distance of 40, that is total distance covered in 3 hours is 140 kilometer. So 140 might be here, right? So here 140 in third hour, and similarly final distance fourth hour you are covering a 200 kilometer, means up to here. Now if you join all this point, what you will get? See the graph. The graph is not uniform, it is not a straight line, it is up and down. So such type of motion is called non-uniform motion. For uniform motion we have a graph like this, right? But for non-uniform motion the graph may be like this, right? Or the graph may be like this, right? This line will not be straight, or this graph may be like this also, right? But if the graph is like this straight line, then the motion is said to be uniform motion. Now let us try to draw the velocity time graph for the non-uniform motion. So here, suppose this is the velocity in kilometer per hour or speed in kilometer per hour, and this is time in hour. So for the first, your speed is 20 kilometer per hour. Speed means distance by time. So 20 kilometer per hour. So 0 here, in the first hour, your speed, your average speed is only, here we have 50, here 100, here 150, 200. But that much speed, we are not moving with that much speed, right? So let me just divide it here. So here, first hour, second hour, third hour. So here 50 kilometer per hour speed, this represents speed 50 kilometer per hour, and this is 100 kilometer per hour. So in the first hour, your speed is only 20 kilometer per hour. So this will be your position in the graph. In the second hour, the speed is 80 kilometers. In the second hour, the total distance covered is 80 and the total time taken is 1 hour. So your speed is 80 kilometer per hour. So in the second hour, you are traveling with a very large speed up to this much. So your speed, your average speed for the second hour is very large. In the third hour, your speed drops to 40 kilometer per hour. Speed means total distance covered by total time. So total distance covered in 1 hour is 40. So here in the third hour, the speed is 40 kilometer per hour up to this, right? And in the fourth hour, the speed is 60 kilometer per hour. You have covered 60 kilometer in 1 hour. So your speed in the fourth hour is 60 kilometer. Now if we join all these dots, so start with here, what you are getting? See here, the speed is not uniform. Initially your speed is slowly increasing, then in the second hour speed is very fast, then in the third hour your speed is average. So here the speed is not uniform, speed is not constant, it is continuously changing. So such type of motion is called non-uniform motion. I hope you have understood this particular part of uniform and non-uniform motion. Now let us try to represent the motion of an object in graph. Generally, we have two types of graph. One is a distance time graph and another is a velocity or speed time graph. Distance time graph can also be called as a position time graph. So here all the graph are position time or distance time graph are given. Now we will try to study different types of motions graphically. So suppose I am here steady, I am just not moving here, I am standing here, and suppose you are standing in front of me at a distance of 5 meter. After 1 minute, 2 minute, 3 minute, right, or 1 hour, you observe that I am not moving, or you are observing any building which is 20 or 30 meter away from you, and you are finding that that building is not moving, the building is at rest, right? So suppose if the object is not moving, then you are observing from the origin and the object is far away at some distance. Let us say this distance is 30 meter or any random distance. Then after an hour you have observed that the object is at 30 meter away. Then another hour you have observed that the object is again 30 meter away. Then what you are observing at all this time, the object is at the same distance. It means the object is not moving. That is, the object is said to be at rest. If you join all these points, you will get this type of line. Right? So this indicates that the object is not moving. See here distance is given, right? If here velocity is given, if the graph is velocity time graph and you get this type of line, then that represent the object is moving with a uniform speed. Velocity is not changing in that case. Here the distance is not changing, right? So this graph represents the state of rest. Now here the uniform motion that we have discussed earlier. So in the uniform motion, the graph is like this, straight line. In the equal intervals, the object covers equal distance, right? So this type of graph is a uniform motion. Now suppose the graph is uniformly accelerated motion. The graph of uniformly accelerated motion. See, uniformly accelerated motion. Accelerated means the object is accelerating. Accelerating means the velocity or the speed of an object is changing. If that speed is changing uniformly, that is, suppose I say that the speed, the acceleration of the object is 2 meter per second square. So this acceleration is constant, that is, the acceleration is not changing. The object is moving with a constant acceleration, right? So in that case, the acceleration remains constant. Now the acceleration indicates the velocity is changing. And if the velocity is changing, what amount? By 2 meter per second. So in the first 0, initially the speed is 0. After 1 second, the speed is 2 meter per second. After another second, the speed is 4 meter per second. So here the increase in the speed is 2, 2, 2, 2. So every second, the speed of the object changes, but the acceleration remains constant. If you don't know about what I am saying, right, then in that case, you need to watch my videos on acceleration, right? So here, the acceleration is 2 meter per second square. That is, the speed of an object increases by 2, 2, 2. So here the speed is increases. So in that case, your motion, so initially you are covering very less distance. So after some time, your speed will be very large and you are covering a very large distance in a short time. So the accelerated motion or the graph of uniformly accelerated motion will be look like this. In a short time, you are covering very large distance. Your speed is increasing. Suppose in this case also, you are observing a vehicle which is at some distance far away from you. Then in that case, suppose at this distance it is observed, and after some time it starts moving with a constant speed. So in that case, you will get a graph like this. If the motion is a uniform, but the motion is not starting from the origin. Here, this is starting from origin. This indicates that the object was at origin. If the object is not at origin and it started motion at some distance from you, then in that case, the graph of uniform motion will be start from here, not from here. If it is starting from origin, then the graph will start from here. Now, let us look at the graph of non-uniform motion. Non-uniform motion, the object moves at different speeds at different intervals, or we can say the object covers unequal distances in equal interval of time. So, the graph, suppose that I have already explained, so I can draw the graph like this also, I can draw the graph like this also, right? So, all these graphs represent non-uniform motion. This is also a non-uniform motion, right? Motion is non-uniform, but in the terms of acceleration, it is a uniformly accelerated motion. So this motion is only a uniform motion. This is uniformly accelerated motion, or also you can say it is a non-uniform motion. And this indicates that the object is at rest. Now let us try to study velocity time graph. Start with the uniform motion graph. Uniform motion means the object is moving with the constant velocity. With the time, the velocity is not changing. So here on the y-axis, we have velocity in meter per second or in kilometer per hour, right? And here we have either time in seconds or time in hour. So suppose the object is moving with a constant speed, it means with the time the speed is not changing. Suppose there is a train which is moving, you are observing the train, and the train initially moving with a speed, let us say 20 meter per second, right? So if that speed continues for 1 hour, 2 hour, 3 hour, right, or for a short time, then with the same speed, then we can say that for that particular time, this train or this object is moving with the same speed, that is the uniform speed, or we can say the object is moving with uniform motion. So here at time 0, the speed is, when you are observing, the speed is 20 meter per second. So after some time, suppose 2 seconds, the object is moving with the same speed, 20 meter per second. After fourth second, you have observed that the object is moving with the same speed. So here, in each time interval, the speed remains same. So you will get a graph like this. So if you are getting this line parallel to the x-axis or parallel to the time axis, and here it is velocity, then the graph represent uniform motion. Suppose you have graph like this, and here you have distance and here you have time, and the line is parallel to x-axis. In that case, it indicates that the object is not changing. S indicates the distance. So at all the interval of time, the distance from the origin is same. Right, the distance is same, that is the object is not moving at all. And here, if there is a velocity and it is a velocity time graph, in that case if you get the same graph, then it indicates that the object is moving with a uniform speed. Now what about the non-uniform motion? In the non-uniform motion, suppose you are starting from your home and you are accelerating, you are moving with a very large speed, then in a short time your speed is very large like this. Then you are reaching in a market and the market is full of traffic. Then in that case what will happen? Your speed will again decrease, falls down. Now you are moving with a very slow speed. Now again you are find a highway or some point where you can accelerate, where you can move with a very large speed. So again, so the graph will be non-uniform because you are not moving with a uniform speed. You can get a graph like this also. You can get a graph like this also. For non-uniform motion, depending upon the object's motion, you will get many type of graph. Right? So this is a non-uniform motion graph. Then, if you have a uniformly accelerated motion, uniformly accelerated motion means the acceleration is uniform. Acceleration is uniform means the change in the speed. Acceleration means rate of change of velocity. That is, change in the velocity, change in the speed is uniform. That is, you are starting with 0 and in the first second you acquire the velocity of 2 meter per second. In the another second you are acquiring velocity of 4 meter per second. In the third second you are acquiring velocity of 6 meter per second. So at each interval the change in velocity is 2, 2, 2. So 0 plus 2, 2, 0, 2 plus 2, 4, 4 plus 2, 6. So here the change in the speed is uniform. The change in the velocity is uniform. So such type of motion is called uniformly accelerated. So initially the speed is 0. After 1 second the speed is 2 meter per second. So you can join 2. Then another second the speed is 4 meter per second. So in the another second, if you join this, so if you join all this line, you will get a straight line. So this indicates if there is a velocity and here you have time, then this graph, straight line graph, indicates the motion of an object is a uniformly accelerated motion. But in the case of uniform motion, and distance time graph, the graph you will get like this if the motion is a uniform. So these two are indicating the same thing. Here it indicates the velocity, the speed of the object is not changing with time, and here indicates that the object cover equal distance in equal interval of time. So both indicate the same thing. Both indicate the uniform motion. So here velocity time graph is there, here distance time graph is there. This parameter is different. Here on y-axis we are indicating velocity or speed, and here on y-axis we are indicating distance. So if the object covers equal distance in equal interval of time, then the object is said to be in uniform motion. That is, its velocity remains constant. So here it indicates the velocity remains constant. So I hope you have enjoyed my lecture. Now in the next lecture we are going to derive the equations of motion using graphical method. Have a nice day.